All right, Math 7, Unit 6, Lesson 15, Efficiently Solving Inequalities. For each inequality, decide whether the solution is represented by A, x is less than 2.5, or B, x is greater than 2.5. So you're going to look at these things here and decide which one makes the most sense. Do you use that value for x or that one, A or B? All right, and that's for you to do. That's your cool down, so I'll let you do it on your own. Number 3. Consider the inequality x minus 1 is greater than negative 2. From the table below, predict which values of x will make the inequality true, and complete the table to check your prediction. All right, so we want to make sure which one's going to make it true here. So if x is negative 2, negative 2 minus 1 becomes minus or negative 3. Is negative 3 greater than negative 2? It is not true. So that's going to be a false statement right there. Not going to work out. All right. How about negative 1? Negative 1 minus 1 becomes minus 2. Minus 2 is greater than minus 2? Nope. That's a false statement. How about 0? 0 minus 1 is minus 1. Now, because we're talking about a number line, a negative 1 is indeed going to be greater than negative 2. So we're going to say true to that one. 1 minus 1 is 0. That's greater than negative 2, so that's true. And 2 minus 1 is 1, and that is also true. Graph the solution set on the number line. So what do we know to be true? Well, here is 0, and 1, and 2, and 3. Here's negative 1, negative 2, and negative 3. Where do things become true at? Things become true when x is equal to 0. So when x is equal to 0, or x is greater than 0, we know that in this case it's actually filled in. And when it's greater than 0, because 0, 1, 2 worked, it's going to be a solution. Okay? Now, because it actually did work there, you might actually shade that in even though it just is a greater than sign, but we know that 0 actually does work okay. Okay? And again, you could solve that by also doing the same. X minus 1 is greater than negative 2. You add 1 to both sides, and then x has to be greater than negative 1. Okay, so what's interesting here, when you graph it out then, when we graph it here, we really should say that it has to be greater than negative 1. Our circle goes there, and we would actually fill this in all the way like this. Okay, so we can't include negative 1, but everything bigger than negative 1 is actually true. And that's the actual way you would graph that out there. We wouldn't graph the 0. So if you just use the table, you might think, I'll just start at the 0 point because negative 1 didn't work. True, negative 1 didn't work, but you know what would work? Negative 0.9. That actually would work okay, and you'd have a solution. So anyways, moving on. Number 4 is the same idea, right? But now we have negative x is greater than negative 2. You want to do some predictions. You want to fill in the table and then make your number line. I would recommend that you still solve this. Negative x is greater than negative 2. I don't really want to have a negative x value there. That's just not going to be what I'm looking for. So if I divide both sides by a negative 1, then x becomes less than negative 2 divided by negative 1 becomes a positive 2. So when I divide by a negative number, I end up with by having to change the sign there, okay? Change the direction of the sign. So keeping this in mind, you can use that to help you with your graph and help you with your table. But I'll let you do that one on your own since it's very similar to number 3. Number 5, which of the following are part of the solution set that makes the following inequality true? Circle your answer. So we're going to look for numbers that make this true. All right, so numbers that make it true, let's go ahead and see what we have here. We can subtract 6 and subtract 6. That goes away. And we have negative 2x is greater than or equal to 22 minus 6 is going to be, in our case here, 16. Okay, so then I'll divide both sides by negative 2, divide by negative 2. So that goes away. And then x becomes, reverse the inequality, less than or equal to 16 divided by negative 2 is a negative 8. So that's our solution. So which ones fit in there? Which values are less than or equal to negative 8? Well, negative 8 is equal to negative 8. That 8's too big. 0 is bigger than negative 8. Negative 8.6 is less than negative 8, and 8.6 is too big. So we have two solutions there that actually make sense. Let's look on the back side. It says to solve each inequality and graph its solution set. And we see that there are basically 6 problems here that they want you to solve. It's a lot like doing the equations we had in prior lessons, but now we have an inequality that we're working with instead of just an equal sign. So I'm going to do a few. I'm going to go ahead and do number 6, I'll do number 8, I'll do number 10. So first thing we do was subtract 7. So we're left with over here, we're left with 15 is greater than or equal to 3x. We're going to divide both sides by 3, and x is less than 5. So what I want to do to graph this here, we're going to graph it up by saying let's go 0, 1, 2, 3, 4, and 5. Put a negative there for fun. I'm going to draw an open circle on the 5 because it's just a less than sign, and x has to be, it can be any value less than 5. And that's it. Number 8, we're going to subtract 3 from both sides. Subtracting is fine. We don't have to change the sign for subtracting. We only change this direction of the inequality when we multiply or divide. Okay? If we're just subtracting or adding, nothing changes. So this becomes x over 3 is greater than or less than negative 3 minus 3 becomes negative 15. Right? The signs are the same, so we're finding the sum. I'm going to multiply both sides by 3. Okay, I multiply a positive number, so I don't have to change anything, and so that cancels out. And x then is greater than or equal to negative 15 times 3 is a negative 45. So if I put negative 45 right here, negative 40, negative 35, and so on, I could draw a circle and close it in because it's greater than or equal to, and draw my arrow like this. X is going to be greater than or equal to negative 45. You know, 0 somewhere out there. Number 10. I'm going to go ahead and first I'll just divide both sides by 2. Nothing wrong with that. So x plus 1 is less than or equal to 10 divided by 2 is 5. Subtract 1, subtract 1. X is less than or equal to 4. So we could do a 0, 1, 2, 3, 4. I'm going to do an open circle because it's just a less than sign, and x is going to be any value less than 4. So I draw my arrow pointing that way, open circle on the 4. Alright, the remaining problems are some review ones from previous lessons and units. It says t-shirts were on sale for $5 off the regular price, the student store. Kieran bought 3 t-shirts for a total of $51. What was the regular price of one shirt? Okay, great problem. So think about this. We have a shirt. Okay, we'll call that X. And we're just going to take the value of that original cost, and we're going to take $5 off that cost, right? So it's $5 off the original cost. We're going to do that 3 times. So let's make this say 3 groups of that happening. When you put all that together, she's going to have a total cost of $51. Okay, so we know we have the original cost minus $5 off. Doing it for 3 shirts is going to be a total of 51. So if we do 51 and we divide it by 3 first of all, then we get x minus 5 equals 17. If I add 5 to both sides, x is going to be equal to 22. So what was the original price of a shirt? $22. How do we know? Well, let's just double check it. 22 minus $5 off is 17. If I did it with 3 shirts, 17 times 3 is what? 21, $51, and yep, check my work, that is going to be correct. So good, $22 was the price of one shirt. 13, a phone which regularly sells for $850 is on sale for 30% off. So what's the discount? Basically, what is 30%? And what's the sales price? That's going to be $850 minus the 30%. Or you could think about being 850 times 70%, because that's what's left there, or 70% of 850. So a couple ways of thinking about it there. So you go ahead and solve this on your own real quick, remembering that 30% can be written as a decimal. The percent as a decimal means move the decimal place over 2 spaces, and you have 0.30 is 30%. That's what you're working with there. All right. Number 14, the last one. Han makes a scale drawing his bedroom using a 1 centimeter to 4 feet. His bedroom measures 12.8 feet by 14 feet. What are the dimensions on his drawing in centimeters? So think of it like this. So he has a 12.8 feet here. He has 14 feet there. He has the dimensions of his room. But in this case here, we know that when we have centimeters and we have feet on this little table, 1 centimeter goes to 4 feet. Okay, that's great. But then we're given this value here. We have 12.8 feet. Okay, so how many centimeters is that? Well, that's a tough one because we're trying to figure out how do you go from 4 to 12.8. I'm not really sure, right? But 4 times some number can get me to 12.8. So I could divide 12.8 by 4 to find out what that number is going to be. So 4 goes into 12 3 times, and 4 goes into 8 2 times, so 3.2. So that tells me if I multiply this by 3.2, I get there. And 1 times 3.2 is 3.2. So this would be 3.2 centimeters. Okay? So my multiplication value to go from centimeters to feet is going that way. Now the next value they give me is 14. So again, I can see, well, how do I go from 4 to 14? I'm going to divide both sides by 4. Okay, so 14 divided by 4, not quite sure what that is. I'll use a calculator real quick. It's 3.5, so x equals 3.5. So to go from here to here is multiplying by 3.5. So 1 times 3.5 is 3.5, and so we're going to say 3.5. And that's what we have there, centimeters. Hope that's right. Just doing it in my head real quick. There you go. That's it for today. Have a great day. We will see you next time.